Now, Alex, would you rather talk about other stuff? Now, the really good news, there's a lot of good news and bad news on this quiz. I graded them each worth 50 points. And I graded them the way the state would have us grade them, which is, and it's good for this because I can grade them quickly. It's either right or it's wrong, or you do something right in between. If it's completely wrong and you do nothing right, you get 0 points. And no. If you are completely right, you get 2 points, Diego. If you do it kind of right, a little bit, anything right, you get half credit. If you do anything wrong, you only get half credit though, too. So I felt kind of bad. There were 2 people who had the right answer, but they put the negative on the sign instead of the positive, or the other way around. And they end up losing just as many points as a kid who only did a little bit right. But this is the way it works. The first thing that you should notice on this question is that they're not lined up. When they don't line up, you go to substitution. Now, a lot of people did substitute correctly, but some people put the x minus 3 in for the x. It doesn't say x equals x minus 3. It says y equals x minus 3. So this x minus 3 has to go in place of the y. It always goes in the place of whatever it says is equals. If it says y equals whatever, it goes in place of y. If it says x equals whatever, it goes in place of x. If it says a equals whatever, it goes in place of a. That's how we do all of this. And then the other mistake that I saw, some people did this properly, but at least 1 or 2 people forgot that -5 times -3 is not -15. What is it? Positive. Positive. I think they forgot that this 5 was negative. Remember, you always have to peek in front to see what kind of number it is. Once you do that, it's pretty easy. 2x and -5x make -3x, subtract 15. 3 and -15 is -12, divide by -3, you get +4. Plugging it back in, y equals 1. And just remember with the check, there was one person who got it beautifully right, did a great job, but they forgot to check. Who was it? Frankie did it? You have to rewrite the original equations, and then you have to plug it back in again. Okay. Next, number 2, solve for both variables, but this time it says don't check. You have to match up. Now, I would prefer to see you match up the 12s here with the B's because the signs are opposite, but you could do the A's, and some people did the A's. Josh?
You won't be penalized if you do check though, right?
No. No, as long as you check correct, they won't get any result. Jamie, can I proceed?
Yeah.
Let's stop talking. Now, once I match them up, the 12 B's go die-die because one's positive, one's negative. That's why I want to work those B's, because I see the opposite signs. It makes it easier. 26A is 52. Remember to multiply everything by 4 over here, everything by 3 up here. Sometimes people forget the last term. Divide, I get A is 2. Then here's my equation. 5A plus 3B is 1. I substitute the 2 back in here. B works out to be -3. Okay? Now, we've done a lot of this kind of work during the year, and I said to you before, this is one of the 2 most important things. The topic that had graphing and these simultaneous equations is one, and the other is what we're doing now. Matt?
Okay.
I will check in just a minute to see what's what with the bathroom pass. Now, let's take a look and go through this, and then we get into today's lesson. Okay? All right. So, Joe had asked to go to the bathroom before you, Matt. So I'm going to just take a look real quick on Joe. Joe, you can take the pass. That's your 4th one. And then Matt, you can go after Joe. That will be your 3rd one. Some of you guys have already hit 5. Yeah, it was Harrison who asked. You asked also? Then you can go after Alex.
literally. Whoa. Wait, did you check me?
Wait, no, who did I just say could go? Matt, after Matt.
Wait, did you check me?
No.
Oh my god.
And then Toledo.
And she
Joe Toledo, it'll be your first. Okay, so. Now, drivers in New York State drive 2.8 times 10 to the 8th miles on Monday. On Tuesday, July 4th, many people drive extra and do an additional that many more miles. Express the total distance driven on July 4th in scientific notation. And I really kind of screwed this up. Because I should have said something like the July 4th holiday or weekend, because I already told you how many they drove on July 4th. It's 9 times 10 to the 8th. So, you already have the answer. Well, let's do what it was intended to do. It was intended to see you add these. And the big review item is that whenever we add in scientific notation, we have to write it out. 1, 2, 6, 7, 8 as a regular whole number. And this one is 2.8 times 10 to the 8th. And then I have to add them up. And we did a lot of work with this earlier in the year, so this is just kind of a review thing. Oh, that's 11. And then count. 3, 6, 9. So it's 1.18 times 10 to the 11th power. 3, 6, 7, 8, 9. Oh, I'm sorry, you're right, 9.
Yeah, I'm just like,
9th power. Okay, 1.18 times 10 to the 9th. Okay, any questions on that? All right. One of the reasons I'm putting these up there, I told you on the state test, the first year, day 1, 7 scientific notation questions. Some were adding, some were subtracting, some were multiplying, some were dividing. So I want to make sure that you're prepared for the kinds of questions that you're going to get. Okay, next up. What is the image of the point 5, -4 after a dilation by a scale factor of -2? Who knows that one? I know it was a long vacation, but this isn't a toughie. I think you can handle this. Matt?
Isn't it -10, 8?
Yep, perfect. -10, 8. Matt, how did you know that?
I don't know, I just knew to multiply.
That's right. That's exactly what it was. Matt knew to multiply. A dilation is to multiply. And he just multiplied each of these by -2. Perfectly done. Next. What's the image of 2, -3 after a reflection in the x-axis? Now, I like to do this. 1, 2, 1, 2, 3. 2, -3 in the x-axis. Count and repeat. 1, 2, 3, 1, 2, 3. That would be 2, 3. And if you remember, we talked about with reflections, if I'm going over the x-axis, the x stays the same and the y switches. What do you remember about if we go over the y-axis?
the Y
The y stays the same and
actually.
the x gets negated. Okay, good. So what about over the y-axis? Well, we know that the y is going to stay the same and the x gets negated, so it's -2, -3. And then a rotation of 90 degrees. That's where we take our paper, we turn it 90 degrees, and you would see if you did that, that you would get 3 -2. Okay? All right, a computer can do an operation in 8.1 times 10 to the -5 seconds. How many operations can it do in 1 hour? So, how many seconds are in a minute? 60. How many minutes are in an hour? 60. So I multiply them out and I come up with 3,600. Now, here's the advantage to the fact that finally I'm letting you use calculators, which I don't think all of you grabbed as you came in the room. I'm going to convert 3,600 to scientific notation, which is 3.6 times 10 to the 3rd. And then I'm going to multiply that by 8.1 times 10 to the 5th. Before vacation, we talked about why this needed to be a +5, because if that's how long it takes to do one, then you can get that many done in a second. For instance, if it takes a half a second to do something, how many times can you do it in a second? You can do it twice. It takes a 1/10 of a second to blink your eyes. How many times can you blink your eyes in a second? 10 times. Okay. So I multiply them, and whatever 3.6 times 8.1 is, then it's gonna be times 10 to the 8th. That's gonna be like probably around 27 point something, and then you have to move the decimal one more place. So I'm just gonna round it off to 2.7, and then this is gonna have to go up to 9, because it is 27 point, I gotta move the decimal back one place. All right, so we've done some scientific notation review, we've done some transformation geometry review, and now we get into a little bit more transformation geometry work. Today's lesson, we want to be able to recognize all types of transformations by looking at them. Davis and Randy. Randy, let's turn face forward. All right, so the first thing you're going to do is tell me what kind of transformation each one of these things is, just by looking at them. What's this one right here? No, I know it is a triangle, but how did it go from the dark red one to the lighter pinkish red one? Translation. It slid, right? And a word for translation is slide. What about the pink pizza slice to the pink pizza slice? It's a rotation 90 degrees. Good. What about brown and blue paisleys? Slide, which is a translation. What about this guy here? It is a translation, right? The R goes to the R. That's the help behind these lines. The Q to the Q, the P to the P, and you know to look for the primes. What about this one here? That's a rotation, good. This one?
Reflection.
Reflection, it's a flip. Flip is a good word for reflection, okay? But you do have to realize reflection is the more technical term. What about this one?
Dilation.
Dilation, it gets bigger. This one?
Dilation.
Not dilation, it's not like we're dialing the phone, right? Dilation, okay. Now, a little bit of practice for you guys. On your graph paper, you can work with your partner next to you. We're going to take the point -2, -5, and we're going to do these 6 transformations to it. Go ahead. Come on, work it out. Let's go.
When it gets bigger.
Is it dial?
It's spelled D-I-L.
It's like dilation.
That's right.
Not dial. I think it was dilation, not dilation.
Dilation. When you go to the optometrist, dilate. Dilate.
I thought it was dilate.
Dilate.
What?
Joe, we're not gonna clap, we're not gonna get the boogie going on there. All right, work on those questions, Joe.
I hate when they dilate.
Can you?
Dilate.
Yeah, can you do your work?
Yeah.
Thank you. Give you guys about a minute. Jenny, Alex, let's work. Right, you should be able to get these 6 transformations in under a minute. You know dilate means multiply, you know how to reflect over the x-axis, keep the x the same. You know how to reflect over the y-axis, keep the y the same. You know how to spin your paper 90 degrees, and you know how to slide. Okay, so there's the point -2, -5. What do I get after a dilation of 4? Everybody? -8, -20. Good. What about a slide 5 to the right and 3 up? Well, you can literally count it on your paper. 1, 2, 3, 4, 5, 1, 2, 3. And that's the point 3, -2. Now remember, you could also add. 5 plus -2 is 3. 3 plus -5 is -2. So you can do it either way, you'll get the correct answer. What about a rotation of 90 degrees? What would we get there? That's it, yep. Spin your paper. What do you get as your new coordinates? What is it? Spin your paper 90 degrees. I think you're going to get 5, -2. Okay, and then remember, reflect over the x, keep the x the same, reflect over the y the same. All calculators go back. Hasta la vista. Bye from you. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Here we go. Garushus. Kadafis. Sayonara.